Hello, this is a video to help you study for your Chapter 8 test in statistics. The first problem is about understanding hypothesis tests. So this claim says most adults would erase all of their personal information online if they could. So that means that if they would erase most of it, if most adults would erase it, that means more than half of it, right? So the original claim is saying that the proportion of adults who would erase all of their personal information is greater than 0.5, like that. So the proportion is greater than 0.5. That represents the claim that most adults would erase all of their personal information online if they could. Now, any claim that involves an equal sign is called the null hypothesis. That claim does not involve an equal sign, so that claim is the alternative hypothesis. So P is greater than 0.5, that's the alternative hypothesis. And the null hypothesis always involves the exact same value. They both always involve the same value. However, the null hypothesis involves an equal sign. So depending on what statistics textbook you're using, sometimes the null hypothesis might say less than or equal to, but it will always involve an equal sign. All right, so that's that. Now let's look at the second question on our Chapter 8 test. It says, claim most adults would erase all of their personal information online if they could. A software firm survey of 480 randomly selected adults showed that 60% of them would erase all of their personal information online if they could. So remember, we already determined that the null hypothesis was P equals 0.5. And so the test statistic is equal to the sample proportion, which it says is 60%, so that's 0.60, and the test statistic is equal to the sample proportion minus the population proportion, which is given in the null hypothesis, which is 0.5, divided by the square root of the value of the population proportion, which is 0.5, times Q, which is 1 minus the population proportion, which is also results in 0.5, divided by the sample size, which is 480. So you do that and you get a value of the test statistic that's equal to that. We'll round that off to 2 decimal places. Now I'll show you another way of doing it as well. You can open StatCrunch, and then you can do stats. It's kind of hard to see. Stats, proportion stats, one sample with summary. And then you can say, now this problem is not designed to use StatCrunch for, so we'll have to do a little bit of extra work because this problem doesn't tell us the number of successes. So this problem is designed for you to do it by hand, but we can calculate the number of successes though. So what is 60% of 480? So what is 480 times 0.60? That's equal to 288. So we actually know that there are 288 successes in this group out of a total sample size of 480. And the null hypothesis is that the proportion is equal to 0.5, and the alternative hypothesis is that it is most adults would erase their data, so that would be greater than 0.5. So if you click compute, it will find the Z statistic for you, 4.38. 4.38, which is the same thing that we got. Of course, it's easier just to do it by hand in this problem. Now, question number 3 on Chapter 8 test. It says the test statistic of z equals 2.04 is obtained when testing the claim that p does not equal that. So when you're testing a claim that p does not equal something, that could mean that it's greater than it or that it's less than it. So when there's two possibilities, it could be greater or it could be less. That's called two-tailed. So this is a two-tailed test. And then it says find the p-value. So what we're going to do when it's a two-tailed test, that means there's both a negative z-value and a positive z-value. So the negative z-value I'm going to look up first. So I'm going to look up negative 2.04 in page 1. So if I look up negative 2.04, so here's negative 2, just a second, negative 2.0, negative 2.01, negative 2.02, negative 2.03, negative 2.04, it's 0.0207, so 0.0207. Now, a two-tailed test, okay, let me just double check that I remember the number right. Yeah, it says 2.04, so we're going to look for negative 2.04. So negative 2.01234, negative 0.1234. Yes, so 0.0207, that's that value that we want. Now, the nice thing about two-tailed tests is that the area that's beyond the test statistic on the right and the area that is beyond the test statistic on the left, they're both exactly the same. So you can simply take that area on the left multiplied by 2, and then you'll get the total p-value. So the total p-value is 0.0414. If I round that off to 3 decimal places, it's 0.041. Okay, now the p-value is, if it's less than the level of significance, then we'll reject the null. But that p-value is not less than that, so we will fail to reject the null. So we will fail to reject the null, and when you fail to reject the null, that means there is not sufficient evidence to support the alternative hypothesis. So because the p-value is bigger than the significance level, we will fail to reject the null hypothesis because there is not sufficient claim to support the alternative hypothesis. All right, then problem 4. Okay, so a type 1 error means that you falsely reject the null hypothesis when the null hypothesis is actually true. So notice that this involves an equals. So this is the null hypothesis. So the proportion of people who write with their left hand is equal to that. So if we falsely reject that null hypothesis when it's true, when it's really true, then that's called a type 1 error. So if we reject the claim that the proportion of people who write with their left hand is 0.32, when that null hypothesis is actually true, when it actually is 0.32, then that's called a type 1 error. So when you falsely reject the claim of a null hypothesis, when the null hypothesis is actually true, then that's called a type 1 error. All right, now a type 2 error is the opposite. A type 2 error is when you falsely don't reject the claim of a null hypothesis when the null hypothesis is actually false. So a type 2 error would be when you fail to reject the claim that the proportion who write with their left hand is 0.32 when the proportion is actually not 32. So a type 2 error is when you fail to reject the null hypothesis which is this, when the null hypothesis is actually false. Okay, now let's look at this problem. So this problem is testing the claim that more than 20% of users develop nausea. So that claim is talking about more. It does not involve an equal sign. So that's the alternative hypothesis. So the alternative hypothesis is going to be more than 20%, and the null is going to involve an equal sign, so it's going to be equal to 20%. And the test statistic is going to be, okay, so the test statistic for proportion, it's equal to the sample proportion, which is 51 divided by 237 subjects, minus the null hypothesis or population proportion, which is 0.20, and then all of that is divided by the square root of the population proportion, which is 0.20, times 1 minus the population proportion, which is 0.80, divided by the sample size, which is 237. So we'll get a test statistic of 0.5846. Now I'll also show you how to do that on StatCrunch as well. So once again, you just use the same thing we did before, stats, proportion stats, one sample with summary. Sorry, you can't see that, with summary. And then the number of successes is 51. There's 237 observations, and you're going to test that the p equals 0.2 versus the alternative hypothesis that it's greater than 0.2. And then you can click compute, and notice it'll show you the test statistic is called z-stat, which is 0.58461282, etc. So it's the exact same number whether you do it by hand like this or whether you do it with StatCrunch. So I'm going to just, it doesn't matter which one you use, it's the same thing. So I'll copy that one. The test statistic is that. Round it off to 2 decimal places, so it's 0.58. Identify the p-value. Now the p-value, unfortunately, you should use StatCrunch to find that. So you really should do this problem in StatCrunch because StatCrunch has the p-value in it. So copy the p-value from StatCrunch. And there is also a way of getting that p-value from a z-table. If you look that z-test statistic up in a z-table and you find the area to the right of it, that's the same thing as, the area to the left of it, that's the same thing as, it is the area to the right of it, because you find the area to the right if your alternative hypothesis is to the right. So you'll find the area to the right of that z-score, and that area to the right of that z-score is equal to that. So that's the p-value. Round it off to 3 decimal places. And is that p-value less than the level of significance? Well, the level of significance is 0.01, so this p-value is not less than that. So when the p-value is not less than the significance, then you fail to reject it, and you fail to reject the null because there's not sufficient evidence. So anytime you fail to reject the null, then there's not sufficient evidence to support the alternative hypothesis. And then question 6 on our chapter 8 test, it says this. So first we have to write the hypotheses. So the claim is that most medical malpractice lawsuits are dropped or dismissed. So the proportion would be greater than 0.5. So look for an alternative. There we go. Now, you might ask yourself, why can't we have a null hypothesis like the one above it that's greater than 50%? Remember though, your null hypothesis always has to involve an equal sign. So being greater than 50% doesn't involve an equal sign, so it has to be the alternative hypothesis. All right, now let's do the test statistic. So once again, we'll do StatCrunch. So since we're still using a proportion again, I'm just going to click on options and just edit those options. So in this new problem, there's 478 successes, and the total number of observations is 805. So 805 observations. And we're going to do a hypothesis test that says the null is 0.5 and the alternative is greater than 0.5. Alright, then click compute. So we get the z statistic, which is that number right there. And I'll put that in. Round it off to 2 decimal places. And then the p-value is also over here. The p-value is less than 0.0001. So if I round it off to 3 decimal places, I just have to put in 0.000. So what's the conclusion about the null hypothesis? Well, we have to check, is the p-value less than the significance level? And in this problem, the answer is yes. The p-value is less than the significance level. So we do reject the null. So we reject the null because the p-value is less than or equal to the significance level. And the final conclusion, therefore, is there is sufficient evidence to warrant the alternative hypothesis, which is the alternative hypothesis. That's the claim that most medical malpractice lawsuits are dropped or dismissed. So there is sufficient evidence to there is sufficient evidence to support the claim that most medical malpractice lawsuits are dropped or dismissed. All right. Then a data set includes data from student evaluations or courses, and it gives us those summary statistics. So what we'll do is we'll go to StatCrunch, and this time when you're doing a hypothesis that involves the mean of something, then you use a t-distribution. So you might remember in some of the examples I had in your homework, there was a table that showed you the different kinds of distributions that you'll use. And so we're testing a claim that there's a mean equal to 4.25. So the null is going to be that the mean equals 4.25, and the alternative, therefore, is that the mean does not equal 4.25. So those are the hypotheses. Is it does equal 4.25, or otherwise it does not equal 4.25. And we'll find the test statistic by going to StatCrunch, and then from the stat menu I'm going to do t-stats, one sample with summary, and then I'll put in these numbers. So the sample mean is given right here, 4.08. The sample standard deviation is 0.66. The sample size is 90. And I want to do a hypothesis test that the mean is equal to 4.25, or the alternative that it does not equal 4.25. So I'll click compute. The test statistic is called t this time, and that's equal to that. And the test statistic can also be calculated by hand, of course, if you do the sample mean minus the population mean in parentheses divided by the sample standard deviation over the square root of the sample size. So the test statistic is going to be there, rounded off to 2 decimal places, and then the p-value is right there, rounded off to 3 decimal places, so 0.017, round that up. Then State the final conclusion that addresses the original claim. Well, the significance level, it says, is 0.05. So since the significance level is 0.05 and the p-value is 0.01, that means that the p-value is less than the significance level. So we are going to reject the null. And when you reject the null, that means there is sufficient evidence to conclude that the original claim that the mean of the population of student course evaluations is equal to 4.25 is rejected, right? So is not correct. All right, now, so we're going to reject that. Then let's look at question 8. Listed below are the lead concentrations in micrograms per gram measured in, which you could also call, I think, parts per million maybe, in different traditional medicines. Use a 0.05 significance level to test the claim that the mean lead concentration is less than 13. So first of all, the claim is that the mean concentration is less than 13. So that's going to be the alternative hypothesis. So it would have to be this one, because the null hypothesis always involves an equal sign, and so the alternative would be that it's less than 13, which was the claim that they gave in the problem. And the test statistic, so what you do this time is you right click on this data icon and you choose open in StatCrunch, and now it has the data in StatCrunch already. Then you're going to do stats, tstats, one sample with data, and you're going to choose the column variable 1, and then you're going to choose the null hypothesis, the mean equals 13, and the alternative is that it's less than 13, because that's just what the problem asked. It says to test the claim that the mean concentration is less than 13. So there we go. And then we'll click compute. So the results of this hypothesis test are as follows. The test statistic is negative 3.169, which rounds off to negative 3.17. And the p-value is 0.0057, which rounds off to 0.006. And the final conclusion, okay, now we have to look at the significance level. It says 0.05. So since the p-value is less than the significance level of 0.05, then we are going to reject the null, which means that there is sufficient evidence to conclude that the mean lead concentration for all such medicines is less than. So when you reject the null, that means you conclude that this one has evidence for it. So we're going to say there's sufficient evidence to conclude that the mean lead concentration for all such medicines is less than 13. Okay, now we'll do problem number 9 on your test. And there's a tip that goes with that says remember that beta is 1 minus the power. So beta is the probability of a type 2 error, and power is the probability of rejecting a false null hypothesis. So it says the hypothesis test has a power of 0.4469. It says supporting the alternative hypothesis, and the actual population is mean is 4.0. So what does that mean? Well, that means that the chance, so that's not a very large probability, right? So the chance of recognizing that the mean is less than 6, the chance of recognizing that the alternative hypothesis is true is not very high, because the power is only 0.4469, when in reality the mean is equal to 4.0. So the chance of recognizing that the alternative hypothesis is true is only 44%, which is not very high, when in reality the mean is 4.0. All right, now I'll interpret the value of beta. So beta is equal to the probability of type 2 error, which is 1 minus alpha. So the value of beta is, so let's do 1 minus 0.4469, and I get 0.5531. So the value of beta equals, so it's got to be either B or C. Okay, so ready? It'd be there. So the value of beta, it says rounded to 4 decimal places. So the value of beta equals 0.5531, indicates that there is a greater than 50% chance of failing to recognize that the mean is less than 6, when in reality it actually is 4. All right. So once again, beta is the probability of a type 2 error, which means beta is the probability that you don't recognize that the alternative hypothesis is true. All right, now let's do question 10. So question 10 and 11 are about standard deviations. So let's look at this data table. Perfect. Okay, so the men in the general population have a mean height of 69.3, a standard deviation of 3.1. So the null hypothesis would be that the standard deviation is equal to 3.1. The alternative hypothesis is that, let's see, a baseball analyst wonders whether the standard deviation of the Major League Baseball players is less than 3.1. So they want to know if the standard deviation might be less than 3.1. Okay, so we are going to open this data table in StatCrunch. So open it in StatCrunch. Now the interesting thing is we're actually missing some info in this problem. So that's the standard deviation, and so we need to calculate the variance. So variance is equal to standard deviation squared. So what we need to do is take the standard deviation value in the hypothesis and then square it. So 3.1 squared is 9.61. That's the variance. So we're going to click on Stats, Variance Stats, One Sample with Data. We're going to select that column. Then we're going to do a hypothesis test for the variance. So the null is going to be the variance equals 9.61, and then the alternative is going to be that the variance, see that one says less than, so we're going to say we choose less than as well. So we have to do a hypothesis test for variance where it's equal to 9.61 or less than 9.61. We have to do this in order to find out the hypothesis test that the standard deviation is equal to 3.1 or less than 3.1. Then we'll click Compute. And so the chi-square statistic is equal to that number. round that off to 3 decimal places, so it'll be 8.42. Instead of 8, it'll be 9. 8.429. And then the p-value is that number right there. And round it off to 3 decimal places. So it'll be 0.018. And what's the correct conclusion at the 1% level of significance? Well, since the p-value is not less than or equal to the level of significance, so since the p-value is greater than the level of significance, that means we will fail to reject the null hypothesis. So we do not reject the null, which means that there is not sufficient evidence to conclude that the standard deviation of the heights of Major League Baseball players is less than 3.1. So basically, in a nutshell, there is not sufficient evidence for the alternative hypothesis. All right, then go to the next question, problem 11. So this problem has even more data. So click on this data icon, and choose Open in StatCrunch. And so, just a second. Now, okay, so test the claim. So let me just talk about this question a little bit. In some banks and some stores, they have separate waiting lines, like maybe 10 different waiting lines. But sometimes in other stores, they have one long waiting line, and at the end of the waiting line, then you go into different teller windows or different checkout windows. So we are wondering whether or not the standard deviation of the waiting times is going to be different. It's going to be less than it used to be. Okay, so the claim is the standard deviation of the waiting times is less than 1.9. So that would be the alternative hypothesis. So right there. So let's see. The null hypothesis is that it's equal to 1.9 minutes, but the alternative hypothesis is that the standard deviation is less than 1.9 minutes. So that's going to be the correct hypotheses. Now, by the way, some textbooks will actually show you that B can also be an option, but in this textbook, they only allow you to use just an equal sign in the null hypothesis. Although in reality, it is possible in statistics, in some cases, to have null hypotheses that have greater than signs as long as they also have an equal sign. So if you've ever had a statistics class with a different textbook before, you might be a little bit confused. So I wanted to make sure that you knew that in this test, the only one that will count correctly is the one that has just the equal sign and the null. All right, now, then you do the test statistic using StatCrunch. So oh, and by the way, we'll have to square those numbers 1.9 to get the variance. So if I take standard deviation equals 1.9 and then I square it, I will get a variance of 3.61. So I'm going to do this. All right, so I do stats, variance stats, one sample with data, select the variable, and then my hypothesis test is going to be the variance equals 3.61, and the alternative is that it's going to be less than 3.61. And then I copy the chi-square test statistic, and then it's 41.808, which rounds off to 41.81. And then the p-value is that 0.044. And then does the use, okay, so let's see. The significance level is 0.05 and the p-value is less than or equal to the significance level. So that means you're going to reject the null. So does the use of a single line appear to reduce the variation? Well, think about this. If you reject the null, if we reject this null hypothesis, that means that there is evidence that the waiting time is less than 1. The standard deviation of waiting time is less than 1.9. So there is sufficient evidence to conclude that the single line reduced the variation among waiting times because H0 is rejected by the hypothesis test. All right, so that's the end of the test. There's just 11 questions. Okay, so I hope it makes sense to you doing hypothesis tests. And those are your review notes for your Chapter 8 test.